Hello class 10. Let's solve the exercise 6.3 of your Ncert book. Question number 9. In the given figure, triangle ABC and AMP are two right triangles. So A, B and C is a right angle triangle and AMP is another right angle triangle which are right angled at B and here at M. So this is 90 degree here and this is also 90 degree here. We have to prove that triangle ABC is similar to AMP. So ABC should be similar to AMP. So in both the triangles we can see angle A is already common and we can see that angle B is equal to angle M because they are 90 degree. So similarly we can use the AA similarity criterion. So angle P is equal to angle AMP because they are 90 degree and angle A is common to them. Therefore, by AA similarity, ABC is similar to triangle AMP. In the second case, they have asked us to prove that CA by PA equals to BC by MP. Let us look in the figure which triangles they are talking about. So, CA by PA is equal to BC by MP. So, CA and BC lies in triangle ABC and PA and MP. PA and MP lies in triangle AMP. Right? We'll take the first triangle from the numerators and the second triangle from the denominators. So we can see that they want us to prove that ABC is congruent to AMP or similar to AMP. So if we can prove that, we can say that by corresponding sides, their ratio are equal. Therefore, this ratio will be true. So we have already proven that triangle ABC is similar to AMP. So from here, we can directly say that the ratio of the corresponding sides of similar triangles are always equal. Therefore, we can form the ratio. Now, it is very important to write down all the ratios and conclude this. So, AC by AP is right over here and BC by NP. And the third ratio would have been AB by AM. We do not need the last one because they have not asked us to prove it. So we have omitted that part. So hence proved. Question number 10. CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on the sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC and triangle FEG are similar, we have to show the following. So let us draw the diagram first. So if these two are the triangles, one is ABC, another is EFG. So we can see over here that CD and GH are respectively the bisectors of ACB. So this is angle ACB. So CD is the bisector of angle ACB. And for the other triangle, GH is the bisector of EGF. So this angle is bisected by GH. So since this CD is the bisector of angle C, we can say that angle 1 is equal to angle 3. These two angles are equal. It is not perpendicular, so it is not 90 degree, but these two angles will be equal. Next, in this triangle, it is also said that GH is a bisector. Therefore, we can say angle 4 and angle 2 are also equal to each other because they are bisected angles. It is already given that triangle ABC is similar to triangle FEG. Since they are similar, therefore we can conclude these conditions that all their corresponding angles are equal. So we can write here, since all the angles are equal, therefore angle A is equals to angle F angle B is equals to angle E, and angle C is equal to angle G. From the name only we can write down the following. And again their ratios will also be equal. Therefore, AB is equals by FE is equal to BC by EG, and AC will be equal to F by FG. Sorry, the last ratio will be AC by FG. So all the ratios will be equal. This is what we have got from this given information, that the two triangles are similar. Now we have to prove that CD by GH is equal to AC by FG. So CD by GH is equal to AC by FG. So we have to take triangle CD and AC lies here. So CD and AC, triangle ACD, and GH and FG lies here. So triangle FGH. So in this two triangle ACD and FGH, we have to prove that these two are similar. If these two are similar, by corresponding sides of similar triangles, we can prove this ratio. So what to do? So here we can see that already it is given that angle E is equals to angle F. So angle A of this triangle is equal to angle F. We can take it as 1. It is also given that angle 1 is equal to angle 3, angle 4 is equals to angle 2, and here it is given that angle C is equals to angle G. Since angle C is equal to angle G, half of their angles will also be equal. So half of angle C will also be equal to half of angle G. So what is the half of angle C? So angle C has been divided into two equal parts, angle 1 and angle 3. So we can say that half of angle C is equal to angle 1, also equal to angle 3. And here half of angle G is equal to angle 4, that is equal to angle 2. So if their half are equal and this 2 are also equal, so can we say that half of angle C is equal to angle 1 and half of angle G is equal to angle 2. So finally we can write angle 1 is equal to angle 2. So we have got two angles here, this 2 and this 2 are equal. Therefore, by AA similarity criterion, triangle ACD is similar to triangle FGH. And therefore, by corresponding sides of similar triangles, we can write that CD by GH is equals to AC by FG. So here is the ratio that we have. Since triangle ABC is similar to triangle FEG, we have this set of relationships with us. Now for the second question, we have to prove that triangle DCB is similar to triangle HGE. So triangle DCB is this triangle and HGE is this one. So we have to prove these two are similar. To prove this, from the previous proof, we have already seen that CD by GH is equals to AC by FG. Now, from this given relation, we can see that AC by FG is equal to BC by EG. So we can write it over here. Now, if we compare these two equations, AC by FG is common in both the equations. So that means that if we compare those, we can easily write down that CD by GH is equals to BC by EG. That is, CD by GH is equals to BC by EG. So we can see that these two sides are correspondingly in ratio with these two. So we can take the angle between them, this angle and this angle. If we can prove that they are equal, then we can use the SAS similarity criterion. So for that, we can already say by this relation that angle C is equals to angle G. Now half of angle C is equals to half of angle G. So we can write angle 3 is equals to half of angle C and angle 4 is equals to half of angle G. So since C is equals to G, therefore ultimately we can write down angle 3 is equal to angle 4. So we have these two sides are correspondingly in ratio with each other and the angle between them are equal. Therefore, by SAS similarity criterion, triangle DCB is similar to triangle HGE. In the next part, we have to prove that triangle DCA is similar to triangle HGF. For this, we can take angle 1 is equal to angle 2 due to the same reason, because angle C is equal to angle G. Then we have this particular ratio which we have already proved in part 1. In part 1, actually, we have already proven that this triangle DCA is similar to HGF. So, but the name was quite different. So, if we have to prove the same thing, we can prove it by the ratio of the two sides and these equal angles, or we can do it in the previous manner as we have done in number 1. So ultimately, since they are bisectors, angle 1 equals to angle 2 and CB by GH equals to AC by FG. Therefore, by SAS similarity criterion, triangle DCA is similar to triangle HGF. Question number 11. In the given figure, E is a point on side CB. So, if we see that CB is a side of a triangle ABC, and this is an isosceles triangle produced of an isosceles triangle ABC with AB equals to AC. So, AB is equals to AC, and if we extend CB, we will get the point E. If AD is perpendicular to BC, that means at angle D we have 90 degree, and EF is perpendicular to AC, that is at angle F we again have 90 degree. Then we have to prove that triangle ABD is similar to ECF. So this triangle will be similar to this one on the left hand side. So since it is given that ABC is an isosceles triangle, we can write that AB is equals to AC. So since AB is equal to AC, we know that the angles will be equal to the opposite sides of the equal sides of an isosceles triangle. So if AB is equals to AC, then the angles opposite to them will be equal. That means angle B here will be equals to angle C, or rather we can write down angle ABC will be equal to angle ACB. Mark it as equation 1. Now, in triangle ABD and triangle ECF, we can write down that angle ABD is equal to angle ECF, angle ABD is equal to angle ECF. We have just proved by equation 1. Then we can also write angle ADB, which is 90 degree, that is equal to angle EFC, which is again 90 degree. So these two are equal. Therefore, since we have two angles which are equal, therefore by AA similarity criterion, we can say triangle ABD is similar to triangle E. Question number 12. Sides AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. Show that triangle ABC is similar to triangle PQR. So here are the two diagrams of the two triangles. So we have triangle ABC and PQR. Here it is said AB is proportional to PQ. Side BC is proportional to QR, and the median AD is proportional to PM. So AD and PM are medians of the two triangles. By median we say they are bisecting the base into two equal halves. That is, BC is bisected into two equal halves, BD and CD. Again, QR is bisected at M into two equal halves, QM and MR. So we can write in triangle ABC and PQR, AB by PQ is equal to BC by QR and AD is equals to PM. This is given. Or we can also write that AB by PQ is equal to half of BC by half of QR. So we already know that if we multiply the same thing in the numerator and denominator, then there is no change in the value. So we can multiply half to both the numerator and denominator and keep rest of the equation same. Now again AB by PQ is equal to, now half of BC is equals to BD and half of QR is equals to QM. Now you may ask why we are choosing these particular side. The reason is that we can see from this particular part that AB by PQ equals to BC by QR. That means this and these sides are proportional. Again, these two sides are proportional. If we can prove that this angle B is equal to angle Q, then we can use the SAS congruence or similarity rule. So SAS similarity rule can be applied here. So for that, we will target on proving angle B is equal to angle Q. And we can do that by proving triangle ABD is similar to triangle PQM. If we can prove that, then we will get the ratios of this proportional sides and the angle between them can also be equal if these two are similar. So therefore, we are targeting to prove these two to be similar first. So that's why we have chosen BD and not CD. Now, therefore, half of BC is equals to BD and half of QR will be equal to QM. Again, we are leaving the remaining same. Now, from this equation, what we can see is AB by PQ is equal to BD by QM and that is equals to AD by PM. That means these two triangles are having proportional sides. So since all three sides are proportional, therefore we can use the SSS congruence rule and we can say that triangle ABD is similar to triangle PQM by SSS congruence or rather similarity rule. Since these two triangles are similar to each other, we can also say that these two angles are now equal. For similar triangles, we have equal angles. So, therefore, angle B will be equal to angle Q as corresponding angles of similar triangles are equal. Now, let's focus on the given question. We have to prove triangle ABC is similar to triangle PQR. So, in triangle ABC and PQR, we can take this relation AB by PQ is equals to BC by QR and angle B is equal to angle Q. That is, two sides are proportional and the angles between them are also equal. Therefore, by SAS similarity criterion, we can say triangle ABC is similar to triangle important sum. Next, question number 13. D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square is equal to CB into CD. So here's the diagram. We have a triangle ABC and D is a point on the side BC. So we have a point BC, side BC, and there we'll have a point D. The point D is constructed in such a manner such that ADC is equals to BAC. ADC is right over here. This angle is equal to angle BAC, this entire angle. This entire angle BAC is equal to ADC. So from there we have to prove this relation. So what we can do is, we can tell that in triangle ABC and triangle DAC, ABC the entire one and DAC this right hand side one. In this two triangle, this entire and this one, we can see that angle C is a common place. So we can write angle C is common. Again, we have the given relationship That is, this angle is equal to BAC. So since two angles are equal here, then we can say by AA similarity criterion, triangle ABC will be similar to triangle DAC. Now, thus their proportional sides will be CA by CD, CA by CD and BC by AC. So we will write over here. Now if we just cross multiply, we'll get CA square is equals to CD into CB. So this is the relationship that we write over here. Now it is a very important thing to keep in mind how to find out the triangles which we have to prove to be similar to get any proportional relation like that. So we have to focus on the end result. So here we have the side CA, CB and CD. So CA is right over here, CB is here and CD is here. That means we have CA twice. So we can take the triangles CA and CD and CA and CB. So the triangle which constitutes of CA and CB is ABC and the triangle which constitutes CA and CD will be ACD. So that's why we have chosen these two triangles. Question number 14. Sides AB, AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. In this given figure, we can see that we have two triangles ABC and PQR, where AB is proportional to PQ, AC is proportional to PR, and the median AD is proportional to PM. We have to prove that triangle ABC is similar to triangle PQR. In a previous sum, we have got a similar type of structure and conditions, and we had to prove that the two triangles are similar. But in that case, the side AB was proportional to PQ, BC was proportional to QR, and AD was proportional to PM. That means these two sides were in proportion with the corresponding sides. So we had to prove that this angle was equal with this one. But in this case, it is said that these three sides are proportional to the corresponding triangle. So in this case, we have to draw a different construction. We cannot just prove from some particular angle. So for that, we will draw DE parallel to AC and MS parallel to PR. Now, by converse of midpoint theorem, we can say that since DE is at the midpoint of BC, as AD was the median, D is the midpoint. So therefore, when we are passing a line through the midpoint of one side of a triangle and parallel to another side, then that line will pass through the midpoint of the third side. So by the converse of midpoint theorem, we can say that E is the midpoint of AB and also DE is equals to half of AC. So E is the midpoint of AB and DE is the half of AC. Similarly, for SM, we can write down the same thing, that SM is half of PR and S is the midpoint of PQ. Now, this condition AB by PQ is equal to AC by PR and that is equals to AD by PM is already given in the question. From here, we can write down AB is equal to twice of AE because E is the midpoint. So AB is equals to twice of AE. Similarly, PS, twice of PS is equals to PQ. Again, for AC, we have this relation DE is equals to half of AC. So we can write down AC is equals to twice of DE. So we'll replace AC by twice of DE And similarly, we'll replace PR by twice of SM by this relation. And we'll look at the third one as it is. If we cancel out the numeric numbers, so we will get AE by PS equals to DE by SM, and that is equals to AD by PM. So if we look into the diagrams, we can see AE by PS is AE by PS, DE by SM, and AD by PM. So that means we are talking about triangle ADE and triangle PMS. So since all the sides are in proportion of these two triangles, we can say that by SSS count similarity criterion, triangle ADE is similar to triangle PMS. So since these two triangles are similar to each other, we can say that angle 1 is equal to angle 3, that is this particular angle is equals to this A equals to P, that is angle 1 equals to angle 3, only this part. So if we take the other triangle, then we can also say from here that angle 2 is equal to angle 4, this angle is equal to this angle. If we take triangles of other parts, so if we see that angle 1 equals to angle 3 and angle 2 is equals to angle 4, then we can write down angle 1 plus 2 is equals to 3 plus 4. Therefore, angle A here is equals to angle P. So since angle BAC is equals to angle QPR, we can write down angle A equals to angle P, and also that AB by PQ is equals to AC by PR in triangle ABC and PQR. So we can see that these two sides are in proportion with these two sides and the angle between them are equal. As a result, we can say by SAS congruence rule, triangle ABC is similar to triangle PQR. Question number 15. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meter long. Find the height of the tower. If you look into the two cases, AB is the vertical pole of 6 meter and BC is the shadow created by the pole, which is of 4 meter. Sorry, it will be 4 meter. Again, we have a tower which is at the same time casting a shadow of 28 meters, and the length of the tower is not given. We have to find the length of the tower. So, when the sun rises during the same time of the day, the angle of the sun ray is same. So throughout the day, whenever we take the length at different points, at the same moment, the angle of the ray or the sun ray is always equal. That's why we can say that angle C and angle R right over here will be equal. Again, since the pole and the tower is perpendicularly placed on the base of the earth, therefore the angle created at the base of the two figures are also 90 degree. So angle B and angle Q is 90 degree. Since angle B is equals to Q as 90 and angle C is equals to R, therefore we have two angles which are equal in these two corresponding triangles. Therefore, by AA similarity criterion, triangle ABC is similar to triangle PQR. Since the two triangles are similar, we can also say from this that AB by PQ is equal to BC by QR, and that is equals to AC by PR. This ratio is obtained from the above relation. From here we know we have the values of BC, QR and AB, and we have to find out PQ. So for that purpose, we will choose the first two ratios. BC by QR is equals to AB by PQ. We will put the values of these particular sides and then calculate the value of H, which will be the height of the tower. So we are calculating the height of the tower to be 42 meter. Question number 16. If AD and PM are medians of a triangle ABC and PQR respectively, where triangle ABC is similar to PQR, prove that AB by PQ is equals to AD by PM. So let's draw a diagram over here. In this diagram, we can see that we have a triangle ABC and a triangle PQR. It is said that AD and PM are medians of the triangle. So AD is the median and PM is the median here. Since they are median, that means that they are dividing the base into two equal halves. So we can say that BD is equals to CD and QM is equal to MR. Now they have also said that triangle ABC is similar to triangle PQR. As because these two are equal, therefore we can say that angle ABC is equals to angle PQR and AB by PQ is equals to BC by QR. Here in the question we said that we have to prove that AB by PQ is equals to AD by PM. So AB by PQ is equals to AD by PM. So they are talking about triangle ABD and triangle PQM. To prove these two are in ratio, we can also prove that these two are similar to each other. If we can prove that these two triangles are similar, then we can obviously prove this ratio. But to do that, we can prove either this angle is equal or the sides are in proportion. By the given condition from triangle ABC and PQR's similarity, we have AB by PQ is equals to BC by QR, that is AB by PQ is equal to BC by QR. So instead of BC, we can write down twice of BD. So BC, half of BC and half of QR can be written, and half of BC is equals to BD. We are aiming at proving this triangle ABD is similar to PQM. That's why we are choosing this side. So similarly for this one also we'll choose instead of QR, half of QR will be equals to QM. So therefore we are having AB by PQ is equal to BD by QM. So we have AB by PQ is equals to BD, right here BD by QM. So if we can prove the angle B is equal to angle Q, then we can say that by SAS this triangle is similar to this. Now we already know angle B is equal to angle Q because it is given that triangle ABC is similar to PQR. So here angle B is equal to angle Q, right? So angle B is equals to angle Q and AB by PQ is equals to BD by QM. So from these two conditions, we can say that by SAS similarity criterion, triangle ABD is similar to triangle PQM. Now since these two are similar to each other, therefore we can write down the ratio AB by PQ is equals to AD by PM. This is what they have asked for. So we will always look into the numerators and denominators of the ratios to find out which triangle we have to work with. Hope you have understood. Thank you everyone for watching.